well into the month of January. Theme for this month, I think, has to do with really cold temperatures and a lack of precipitation or snowfall in some cases. We'll talk about a variety of things related to our climate. General information, you've probably seen this slide a few times. The regional climate services for the north central U.S., including the Great Plains and Midwest, are provided through collaboration among federal, regional, and state partners, including various NOAA offices, state climatologists, Midwestern and High Plains Regional Climate Center, the USDA Climate Hubs, the National Drought Mitigation Center. Next webinar will be February 15th. Still waiting to determine who the author or presenter will be for that, so stay tuned for that. And you can access past webinars, and we'll be able to see an archive of this one on any of those three sites through the Midwestern Regional Climate Center, the High Plains Regional Climate Center, or the drought portal that NIDIS operates, drought.gov. Today, as usual, we're going to talk a little bit about current climate conditions in a historical perspective, take a look at some current and prospective climate impacts associated with those conditions. We'll look at the most recent outlooks that were just released, and then have some time for questions, answers, and any further discussion. So first of all, since we are in the new year, we'll look back at 2017. It's our opportunity to do so, and looking at statewide average temperature and precipitation ranks. Certainly 2017 stands out as an extremely warm year, and in some cases a record warm year in the U.S., and in all cases a year that was much above average in terms of temperature. And if we were to delve into that a little bit more, we would see that a significant component to those high rankings came from the early part of 2017. That really helped to get it off to a very, very warm start. Statewide precipitation ranks, it was generally an above average year for most parts of the United States, with a few exceptions there in the northern plains and in the southwest, but otherwise near average to well above average record wet conditions in Michigan. If we break down and look at the last 3 months, October through December, again, we see still warm temperatures, but not as warm, not as high in terms of rankings, except warmer conditions starting to set in the southwest and to the west coast. But otherwise, the north central region, above normal to near normal temperatures, and precipitation, starting to see some dryness show up over that 3-month ranking when you get down to Kansas and Missouri, and then look at North Dakota. And to me, again, I'm sitting here in Kentucky, but it's very interesting that we have one of the driest seasons in North Dakota, but an above average one next door in Montana. And of course, we're looking at some pretty large land areas comprising those states. Moving on to just the past month of December, looking back again, temperature ranks now dropping down to right near normal, near average temperatures throughout much of the north central region, with some areas a little bit above average. And then precipitation, again, this emerging theme of dryness starting to set in. Again, look at Colorado, Kansas, Nebraska, Iowa, Missouri, Illinois, and on there. Several states that are below average to much below average in terms of precipitation during that month. Probably not a major issue because December is not necessarily a month that we count on for heavy precipitation, but nonetheless something to pay attention to. Moving on to maps for the region, from these maps from the Midwestern Regional Climate Center, looking at month-to-date average temperature for January thus far, and then going back a little farther for the last 30 days back into December. And you can see that there's a little bit of difference, but a similar message there. Month to date, just recognizing what we've observed, that we've had extremely cold conditions in the Midwest, lower Midwest being much below where it normally is, and cold conditions through the upper Midwest and the plains, with warmer pattern as we go farther west in Colorado, Wyoming. And again, you see that same thing in the 30-day picture, a little different positioning of the coldest temperatures, but make no mistake, for most of the region, we've been well below average in terms of temperature. Moving on to precipitation, as a percentage of mean precipitation, these maps are a little bit more difficult to discern patterns. There's a kind of a mess of above and below average. But if we study those a little bit, we can see that through much of the Midwest and part of the Great Plains, again, precipitation has been below normal. We've got several areas that are in the 25 to 75% of mean precipitation for the reference period of 1981 to 2010. A little bit more moisture in the Ohio River Valley coming up through Kentucky, parts of Indiana, Ohio, and wetter conditions when we get out to Montana, and a little bit more so across the northern plains. Some snowfall that's come later on after a poor start to the early snow season in some of those areas. 7-day average stream flows. You can see on the map we don't have a lot of stream flow data coming out of the northern or upper Midwest and northern Great Plains, just because of very cold temperatures and freezing conditions. But you'll notice a lot of blue showing up, particularly through the Midwest and the Ohio River Valley, the upper Ohio Valley, reflecting some storm events, and then also the recent melting. We had a warm episode with a couple days of temperatures reaching into the 50s, some record-breaking temperatures in parts of Michigan, and so we've had some melt in addition to the precipitation. So no major flooding, some flooding there, some ice jams and such, but nothing major. And then getting in again to the area Missouri, Kansas, Illinois, very, very clear signal of below normal stream flows in those areas, and looking at a lot of monitoring coming from tributaries, but again, those low flows are also impacting flow on the Mississippi. We'll talk about that a little bit later. Snowfall percent of mean. Again, this is very similar to the last slide, because much of that precipitation has been of a frozen variety, and you can see patterns where there's generally been deficit precipitation over a large portion of the region for the past 90 days, picking up a little bit on the left when you look at the 30-day map, starting to recover a little bit from a slow start to the snow season. Snow depth map for the region, again, shows a large portion almost either free of snow or anywhere from a trace to 2 inches. And then when we look at really deep snow depths, you have to get out into the mountains, Wyoming, Montana, to start to see some of those. Snow cover across the northern tier, really not that impressive this year, with the exception of some areas that received probably above normal lake effect snows, with the weather pattern bringing that air masses over the open waters that are now freezing, produced some heavy amounts, and we saw some of that on the news. Snow water equivalent map, and see that with the snowfall and snow cover that we have, really not a lot of water equivalent in that snow. And several comments about just how dry the snow has been, a lack of water content in it. So a little bit deceptive even in areas where there seems to be a decent cover on the ground. And again, kind of reflects the weather pattern where our systems have generally been coming out of the northwest and not a lot of moisture with them. Next map is looking at snow water equivalent, looking at kind of snowpack in the mountains in the western portion of the north central region. And the key theme here is the very obvious distinction, really two stories to tell. If you look at the northern portion of the region, the snow water equivalent from the snowpack is either a normal to above normal, up to 125, 150% of normal. But once you get down farther south, get down into Colorado, you talk to folks there, and they've got a different story to tell, and that is reflecting a lack of snow cover, lack of snowpack, and certainly some expressions of concern at this point, but recognizing that we still have quite a ways to go in the winter snow season.
So, Stuart, can I just say a couple things right there?
Sure.
So a lot of this, it's hard to see the states in here. So I want to make sure people sort of understand that the northern portions where it's green and a little bit of white, most of that's in Montana, but as you go a little bit further south, let's say in the middle part of that map, those are basins within Wyoming, and they more or less flow to the north. And then once you get into the sort of the tan colors where you're seeing a deficit of snow, snow water anyway, that's southern Wyoming and Colorado basins that pretty much feed a lot of the North and South Platte rivers, as opposed to the headwaters, if you will, of the Missouri. So those are the distinctions. Those are sort of the geographies that we're talking about when we look at this particular map.
Yeah, appreciate that clarification, Doug, and your points I think will show up here in the next couple slides. So we've got a time series graph of the mountain snowpack at a couple locations in the upper Missouri Basin, and you can see the progression from October, November, December, so forth as we move through the season. That both in the area in the upper portion of the basin above Fort Peck, and then coming down a little bit lower from Fort Peck to Garrison. In both cases, we're looking at totals that are progressing very nicely and have been and remain above average. They're 114% and 126% of average, so things are looking quite good there. But then as you go a little farther south into the Platte, the snowpack is not accumulating at the rate that folks would like to see, and I think reflecting some comments that I saw, consistent with the pattern we've seen in the last few years, but in both cases for the North Platte and South Platte, 79%, 77% of average, and that's been pretty consistently below average since the start of the season. But again, there's plenty of time left, but we're not seeing any change up to this point in terms of the rate of accumulation there. Move on to soil temperatures. Been a topic of conversation throughout the region with the very cold temperatures and the lack of snow cover or else a shallow snow cover. We've seen some pretty low soil temperatures. This is a map from the Midwestern Regional Climate Center, bringing in data from a variety of mesonettes in addition to various federal networks, showing 4-inch soil temperatures under bare soil and under sod. Got a lot more data coming from sites under sod, but again, you can see the picture there with 4-inch soil temperatures down anywhere from less than 20 degrees in the northern plains, and when we get down to the southern tier of the north central region, we're looking at readings that are in the 30s in the far eastern area, Kentucky and Ohio, some cases where we're about 35. And that's just looking at a 24-hour period there, so that can fluctuate a little more quickly and should change a bit when we get a warm up here in the next few days. Otherwise, frost depth, looking beyond just the 4-inch temperatures, we can see that frost depths across the region, when we get up into the Wisconsin, Minnesota area in particular, we're looking at depths anywhere from a foot to 2 feet deep, in some cases more than 3 feet deep in terms of frost depth. So some raises some questions as to what that might mean for wintering of insects, pests impacting agriculture and so forth. Again, probably too early to tell, but something that's on some people's minds at this point. Move on to a map looking at temperatures and ice forming over the Great Lakes. Again, we saw in the national news back in December all the lake effect snows impacting the Buffalo, Erie, Pennsylvania area and such. Snows from snows coming off of the of Lake Erie. Well, Lake Erie is for the most part frozen over now, and you can see that the projected maximum ice cover is about 33% now, projected to hit up to about 60% at a peak, be a little bit above the long-term average. So it's all coming from our folks at the Great Lakes GLESA, and appreciate that information. Some projected ice coverage peaks or maxima for the different lakes you can see there. So still have a lot of open water, but gaining ice quite quickly. And if we look back at the projected maximum ice coverage a month ago, it was much less than 60% that we're looking at now. And all in all, when you put all of that together, it's just been a cold, nasty winter for a lot of folks. The accumulated winter season severity index, see a lot of blue and purple, and look at the legend there, seeing those classify as severe and extreme weather conditions, and looking at a variety of indicators in terms of snow depth and cover and temperatures and such, to try to put together a composite index that kind of tells us what we already know, that it's been a rough winter for a lot of folks. So moving on now to drought conditions. The U.S. Drought Monitor update from earlier today. We can see we're starting to get a little more coverage, a little more yellows, and even some orange and tiny bit of red, which we don't care to see, but starting to show up across the region a little bit more. If we think back to last year, it was all in all a rather benign year in terms of drought, but we're starting to see some concerns of dryness starting to creep in, and again, doesn't mean a whole lot right now, but if the pattern persists, it suggests that we're in a situation where conditions could deteriorate rapidly later on, but we're not at a point of calling that to happen. We'll look a little bit more closely at the drought outlook later on in our presentation.
Right, and Stuart, I just want to go back and say benign except for the northern high plains.
Yes. This next map is looking at the 1-month change, so we can get an idea of the rate at which drought is intensifying or being alleviated. And again, we can see a 1, in some cases a 2, even a tiny bit of 3-class degradation, where conditions have deteriorated pretty quickly in parts of Colorado and Kansas, and starting to see some dryness develop in parts of Wisconsin and some other patchy areas in the Midwest. Some improvement occurring with the above normal precipitation up in Montana in particular. So that's a summary of current conditions and how they've evolved recently. And now we'll move on and talk just a little bit about impacts from an agricultural perspective. And I think we had this on the call last month, discussion of the event, particularly concentrated in Nebraska, where we had very high winds, high sustained winds that put corn on the ground before it could be harvested. And of course, that corn has stayed there and we've got a lingering concern now about what that might mean for the spring planting season, where we again have all those ears on the ground now. So that story is not going to disappear, I don't think, not in the short term. Potential damage to wheat due to shallow snow cover, cold temperatures, and late planting. Some concerns from Kansas to farther north to the Dakotas. Really too early to tell what that's going to mean. There's a process of growing wheat is a long journey from this point to harvest, so a lot could happen, but some concern in areas where, again, we had a late planting due to some wet conditions early, and then had the very cold temperatures, and in many areas didn't have the snow cover to provide the insulation for those plants as they start to germinate and develop. Drought impacts been observed across the region. Certainly got some feedback from Pat Ganan there in Missouri with impacts there. We've got an image of a dry stock pond in Missouri. So issues with getting water to livestock and being able to have enough feed. And of course, with the cold temperatures, makes that even a more critical issue. Some concern about exposure of livestock to cold temperature and wind chill, and especially with the rapid onset of those cold temperatures there at the beginning of the month. So may have had some adverse impacts and led to some mortality in parts of the Midwest. Stream flows, again, deficit precipitation combined with freezing conditions have resulted in low stream flows in many areas. Again, we noted earlier there are some areas that have had above average stream flows, but much of the region it's been the opposite situation. Ice jams have been common from the upper Ohio River Basin, where they have accentuated some minor flooding issues with some of the snow melt and precipitation. And then farther west, getting out into, again, the Montana area and upper plains, ice jams, pretty common thing, but with the lower stream flows, maybe not as much of an adverse impact at this point. But again, with the low stream flows and the amount of water that's tied up in ice right now, flows on the Mississippi River near St. Louis have been well below normal, something to keep an eye on going forward as to what that might mean for the transportation industry. And finally, impacts in terms of energy. It's been cold. People have been turning the heat on and looking at natural gas consumption. The week of January 5th, when we had the cold weather really set in, broke a record for the largest weekly storage withdrawal of natural gas, basically reflecting a spike in demand for natural gas, and the price for natural gas on spot markets peaked, hit a peak that week, and has since dropped off with the return of warmer temperatures for 2 or 3 days. But certainly some concerns about increased energy consumption, energy use in some of these areas. So moving on to outlooks, 7 days out in terms of precipitation forecast, again, projecting to see a little bit of change in general circulation pattern, some precipitation expected through the part of the Mississippi Valley, Ohio Valley, northern Midwest or upper Midwest, and still look to add some to the snowpack, but again, otherwise we're looking at some fairly minor totals, which is typical for this time of year. Moving on to the 8 to 14 day outlook, I think a lot of people are happy to see this showing an enhanced likelihood of above normal temperatures across much of the Midwest, and probably closer to normal conditions over much of the plains. And you can see a little bit of below normal, enhanced below normal in the Pacific Northwest there. Along with those warmer temperatures, an enhanced probability that we will be wetter than normal. And again, that may be welcome in some areas, but may not have as much influence over the plains at this point. Again, it's just an 8 to 14 day period. La Nina, been a conversation now for a few months that we've been in one. The weather pattern that we've seen has been, broadly consistent with a La Nina pattern. Again, we've seen this graphic many times in the upper left, and then the probabilistic forecast is showing a high likelihood that La Nina conditions will continue through the winter months, but as we move into the spring and summer, we expect those conditions to revert back to a more likely a normal INSO pattern, normal pattern in the equatorial Pacific, and then looking out to the summer, late summer into the fall. Again, no real strong signal one way or the other as to whether we may be switching to an El Nino. That'll become a little more evident in the coming months. So reflecting that La Nina signal in terms of our outlook, again, you can see the temperature outlook for February. Those colder than normal temperatures have an enhanced likelihood in the northern tier, particularly in Montana, equal chances of above or below normal or near normal temperatures throughout much of the region, and above normal to our south. Precipitation, again, classical signal in terms of enhanced likelihood of above normal precipitation from the Ohio River Valley up to the upper Midwest through the month of February. Looking at a seasonal perspective, February, March, and April, that 3-month period, again, enhanced probability of colder than normal. So maybe a colder start to the growing season, perhaps. And again, a continuation of an anticipated wetter than normal pattern. Again, we haven't seen that so much up to this point with the particularly cold temperatures and such, but maintaining that outlook for a La Nina sort of pattern. And then looking forward beyond that, from the May, June, July season, once we get well into the growing season, and again, this is very preliminary. We're looking at 6 months, 3 to 6 months out. That's quite a difficult thing to do. But you can see a lot of orange and red over the U.S., not so much over much of the north central region. Equal chances there of above, near, or below normal temperatures. And precipitation likewise, no strong signals through most of our region. Slightly enhanced likelihood of wetter than normal conditions in the upper Midwest. But while we're focused certainly on the north central region, I think a lot of folks, especially those engaged in agriculture, certainly interested in what patterns might be projected in other regions of the country. A drought outlook. Areas of brown there showing that drought conditions that have developed are likely to persist. What we don't like to see is that a yellow pattern where we see anticipated expansion of drought development and creeping farther across Kansas, Colorado, and moving into Nebraska. Some concerns there. Some improvement expected in the upper plains, but again, not everywhere there. And then some improvement likely in the Missouri area, and otherwise through much of the Midwest. Either no major concerns at this point, or none expected to develop with this projected above normal enhanced likelihood of above normal precipitation in the outlook. So to summarize all of that, it's been a cold winter, but conditions are expected to moderate here going forward. Snowpack is approaching normal conditions in the Missouri and Platte River basins, approaching above normal in the Missouri, approaching that in the Platte, but definitely below normal as we look farther south across much of Colorado. Dryness becoming an increasingly noticeable issue. particularly across the Great Plains, southern plains in particular. La Nina likely to diminish into the spring season. So that's all I've got to present, and I'd like to move along, show some additional information again, where you can find again recordings of past webinars, links to some of the information you saw here, and other information that might be helpful to you in a decision-making perspective. And then we'll have some time for questions. So I'll send it back to Doug and let you take it from here.
So thank you very much for that presentation. Hey, we're going to go over a couple questions, and I think I've gotten to the bottom of why nobody was alerted, at least from what I can tell, nobody was alerted that this webinar was going to happen, and we'll set those alerts up after this webinar again. I can't do it on the fly. I tried. Anyway, let's get on to the questions, and I want to mention that also on the phone with me is Dennis Toddy, who is the USDA Egg Hub Director in Ames, Iowa. A lot of us on the phone, or not so much me, but others on the phone have quite a bit of background in agriculture, and it's always good to have someone who's a climate ag dude on so he can answer some of these questions, like this one. So Benjamin Diamond asks, could you describe what frost depth is and how it would impact agriculture? And I'll simply say that frost depth, and then Dennis maybe, or Stuart for that matter, can talk a little bit more about the impacts of that agriculture and beyond, if you'd like. So frost depth is the depth at which the actual soil is frozen. So if you go out with a spade right now in your backyard, assuming that you're anywhere within the Midwest, and try to dig, you're not going to be able to dig very deep. In fact, it's going to be very chippy. So that depth in which the soil is frozen can be anywhere from a couple inches on the top. Sometimes you'll have, if it's been warm for a few days, you'll have 2 to 3 inches that have thawed, and below that for a foot or two, it can be solidly frozen. And as you might suspect, the further north you go, the longer you have colder temperatures, that frost depth tends to be deeper. Things that sort of alleviate that are an early snow cover. Snow tends to protect, if you will, the soil beneath it from harsh temperatures. That's key to getting wheat to grow, especially winter wheat, things like that. It's nice to have a layer of snow over the top of that. But I'm getting into subjects I know less about. So you two guys want to expound upon the impacts of frost depth and how that could be an issue?
You want to take any of that, Stuart, or should I go?
I'll let you go ahead with it.
Okay. As Doug did a nice introduction there, part of the issues we've had with frost depth here, one, we got cold before we had snow cover in some of the areas, so that allowed the soil to start to freeze a little more readily before we had snow cover on it. And we have very dry soils. Very dry soils don't have a lot of water in them. Water has a very high heat capacity. Therefore, soil with a lot of water in it, it warms up very quickly. Or excuse me, soil that does not have much water in it warms up and cools down very quickly. And since we have very dry soils, it allows the frost depth to penetrate fairly deep. And that's why the main issue when we're dealing with frost depths are water lines, because they are buried. If they were not buried to a proper depth, most codes in most cities have all water lines and things below the depth where we typically freeze. But back in 2013 and 14, when we had a persistent cold stretch with similar conditions in the soil, we did have some water lines freezing in some cities and some areas. The impact to agriculture is less. It can be a problem with some dormant plants in the ground, like a winter wheat. Snow cover is better for them to help protect against that. But if most things that we grow around this area are developed to be able to stand most of the typical conditions. So that's the main concern we have with frost depth is urban Camden water lines could be a problem, maybe in accessing water for livestock or something like that.
Yeah, and Chip Zimmer is and you may know him, Stuart, has also said there's a big impact in eastern Kentucky. There's been water shortages due to cold weather causing a number of water main breaks. So those are not uncommon necessarily in Kansas City either, but they tend to happen in the middle of the summer for some reason. So it's an old system. It's being replaced. Okay, the next question I have is, could you explain more about the Aussie, the weather and the winter weather index, severe weather index, and its impact, also its impact to agriculture? And you know, I think I can talk sort of peripherally about this. This is simply a way to gauge this, if you will, the severity of a winter compared to other winters. From a temperature as well as snowfall amount. And there may be a few other variables in there, Dennis and Stuart, I'm not sure. But the more severe, obviously, the more impactful. Generally speaking, this winter has been not so much the snow, unless you're around the Great Lakes and such. Snow has not been a huge issue. It's been the unrelenting cold for a few weeks in a row. Anything you want to say about that, guys? Anything extra?
Yeah, I think you captured the general concept of it pretty well. We don't have Barb Mays on the call, do we?
Oh, that's true. She is on the call. Hey, yeah. Here, let me just tune her in here. Barb, if you want to say something, I'm allowing you to talk.
I'm okay, Doug, but thanks.
Yeah. Oh, you're okay. You don't want to say anything?
I missed the question, to be honest.
Oh, well, it was a question about the Aussie. And
I'm so sorry. Go ahead.
And it was really, could you explain more about the Aussie and its impact to agriculture? And really, it's not so much an impact to agriculture per se. We were trying to describe it as a way to compare winters to each other from a severity aspect, from a temperature and snowfall point of view.
Yeah, that's right. And, you know, it doesn't directly include or indicate any kind of ag impacts. They can be implied depending on the severity of the winter, and especially depending on whether it's a snow-driven severity or a temperature-driven severity. But it's basically meant to be a background index on which things like the ag impacts could be scaled with some further work and research.
Yeah. And this particular winter, Barb, can you just generally describe it for this region?
So generally, we've had a west to east gradient this winter, and in the eastern part of Central Region over toward the Great Lakes, the severity has been driven quite a bit by snow along with some cold outbreaks. They've had, as you've seen on the map, the blues and purples, some severe to extreme conditions, Michigan, near the Great Lakes, maybe the northern parts of Minnesota. The further west you go, the less it's been a snowy winter, and especially toward the southwestern part of Central Region, Colorado, western Kansas, parts of Nebraska. Also, there have been some cold air outbreaks that have driven some blips, if you will, in the Aussie, some upward ticks that then level out when those conditions don't sustain themselves. So there have been some fluctuations, for example, in the Central Plains, where for a little while at this winter, we were ranking in the severe category because of recent cold outbreaks. But as that gets past and we're a little closer to normal again, we're not accumulating the points quite as quickly, and we're normalizing much closer to average conditions now.
Okay. Thank you. Thanks, Barb.
Sure.
Can you back up one slide, please, Stuart? Okay. I had a request for someone to see that. The other thing that another commenter, Diane Mankleger, comments on is that with the lack of much snow cover, especially in the plains, the normal, if you will, fire season tends to expand in terms of time. So places from Texas to North Dakota and places east and west of that slightly. If there's not a great snow cover, it doesn't take obviously much to get rid of whatever snow is there. And then you're starting your fire season, say, a little earlier than you normally would. I think there were some relatively big fires in December, actually, Black Hills and such. I think we commented on those the last time. And that's primarily due to lack of snow cover, a lot of wind, of course, but that's not that unusual for that part of the country. I'm not sure who would like to handle this one, but and I'm not sure what the answer is, but maybe if you would go back to the Great Lakes map you had up there, Stuart, and it was Great Lakes ice cover less than average or more. And I don't remember if you actually had numbers on that.
Yes. There. And again, I got some information provided to me that again, currently there on the slide, we've got 33.1% coverage. The long-term average peak coverage for the season is 55%, and they're projecting that this year they'll reach 60%. And that's for the lakes as a whole. And again, you can see the percentages projected for the individual lakes there in the lower left.
So what are we at this moment?
33.1% for the lakes as a whole.
Okay, so about third coverage. All right.
Yeah.
And I see Erie.
I was going to say, you can look at the legend there in terms of median ice concentration in the shades of gray. Looking on the map, the areas that are in shades of gray to black are areas that have already iced over, and then otherwise, the areas that are in shades of blue are looking at water temperatures there of the open water.
Okay. Increase. Oh, yeah. This is a good question. I was going to bring this up as well. A follow-on question to that is increased risk for lake effect snow with less ice coverage in Great Lakes region. Absolutely. And we've seen that because the fall was relatively warm, and those lakes did not cool down. I would say, I'm going to take a flyer on this and say that not as quickly as they normally would, and thus the temperatures when the really cold air came were at least slightly above normal, which you can still see many of the lakes still open and quite a bit of snow potential. It needs cold air, of course, over the top of them to have that. We had a guy state climatologist actually in Michigan say it was 10 to 15 degrees warmer downwind of some of those lakes during some of that bitter cold temperatures across the Midwest because the lakes modified the temperature near shore, if you will, just off the lakes. So it's a pretty amazing thing, apparently, to live in and near some of those lakes where you get hundreds of inches of snow, especially in the upper peninsula of Michigan. Any comments from Dennis or Stuart on that? Any other comments on lake effect?
Yeah, just to add that, following up what you said there, Doug, with things freezing over now on Lake Erie, so all that we read in the news about the city of Erie, Pennsylvania, getting the heavy lake effect snow, that's not going to happen going forward because that's frozen over now.
Right. Good point. I think we've covered everything. If anybody if they want to, actually speak, feel free to hold your hand up and either speak or ask a question. I should have said that you can do that at any time. One thing I'll quickly say, and maybe Dennis and Stuart want to comment on this as well, is, we try our best to, obviously we show you the outlooks, and actually if you go down the outlooks, maybe February, March, April, we do our best to try to use this information to talk about things specific to our region, and actually, why don't we go down to the drought outlook as well? One of the things that I'll say is a concern, but it's certainly not a forecast for. Now, I want to be very careful in saying that. Is this concern for growing the drought, if you will, or increasing the drought areal coverage this spring, and we all know it's a concern anytime you have a drought. But I think especially this year with this La Nina signature and everything else going along with it, we will probably be watching especially closely the southern plains, Southwest, obviously, and Colorado in particular in terms of snowpack and how that evolves. So right now it doesn't look so great, and the longer term, if you will, outlooks don't also. So it's something it bears watching, especially if temperatures, like this is showing you on the left there, if temperatures continue to be above normal, that's also not a great sign. And there's indications there for May, June, and July of although slight indications, but there are indications of being sort of dryish, Four Corners and east, actually in north, as far as that goes. So, yeah, so I think right now that's one of the major issues we're watching.
Stuart, let's go back to the drought outlook for just a minute. I think there's something else that bears talking about here is what this is trying to tell you is the change between now and April 30th on where the change is going to be. And there's a couple things that come into play here. One is the outlooks. Do we expect to have below or above average precipitation over certain areas during that time frame? The other part that goes into it is climatology, because as we get into the spring, most places in our region have more water precipitating than goes into evaporation. So we usually gain ground in the spring because we get more precipitation. So that all it kind of factors into this also. So that's why you see some of the improvement possible in Missouri, Illinois, and some of that in the northern plains. But some of these areas we're pretty entrenched, and we have some very dry soils, some low water levels in wells, and we've got some fairly serious issues still ongoing that we need to resolve before we can remove drought from those areas. So we're layering these factors as to, Doug is not saying we're expecting really bad drought again this year, but we have some issues, and right now our optimism towards resolving those is not very good.
Now, a positive side, trying to look for a silver lining, is that.
Thank you, Stuart.
Yes, there's no indication at this point that we are expecting a bad flood season in on the Missouri.
That's true. That's true.
And the other positive side is that one of the issues we tend to have in agriculture in the spring is sometimes delayed planting because of wet soils. Probably less of an issue this year, the way it looks right now, than in some other years. So some earlier planting or near average planting would be more likely.
Right. Okay, I guess we do have another question here, or a couple more. A few more questions. How warm was 2017 in comparison to former years? Well, yeah, I think again, I'm going back to memory here. I think the U.S. in general, it was the third warmest. Is that correct, guys?
I think that's what we saw.
I think it's also true for the globe, third warmest year on record in 2017. Now, if you're talking about our region or this sort of north central region, I don't know where to put it, but it certainly wasn't the top three.
Stuart, go back to your ranking one on slide.
Oh yeah, slide 2.
Yeah, I think a key component of this is that when you look at the year, again, it was certainly a very warm year. But if you were to break it down by by season and such, much of that warmth was really a continuation from 2016. And I know, and from Kentucky's perspective, January and February of 17 ran about 7 degrees above normal both months. And so we were off to such a warm start. And as we got into the summer, summer was much more pleasant relatively speaking, but when you average things out over the whole year, it was certainly a very warm year.
Yeah, and really you can see there almost every one of the states reported, top, let's see, 123 years, top 10, if you will, type of warmness.
Yeah, but when you get down to, again, the last 3 months, and again, we don't have the other seasons, but as we got later in the year, certainly we didn't end up the year as a very, very warm season.
No. Okay, and then we have, looking at South Dakota, go back to the forecast maps, probably the February, March, April. The question from Dawn Brand is that looking at South Dakota, what makes the line between the southern brown area and the northern green tan areas? Yeah, so I think you're, let me just make sure here. So I think you're talking about temperature, and so the green areas are enhanced probability as opposed to an amount, but enhanced probability of more than normal precipitation for that 3-month period. That's what the green is. And I won't go into in depth about what percent you're at here, but it's greater than, it's a greater than 33% chance, but not much, that you're going to be normal or wetter than normal. I'm sorry, wetter than normal. And there is a, 67% chance, hang with me here, that if you show anywhere in the green area, there's a 67% chance that you'll be at least normal, if not greater than normal. I think I'm saying that right. The brown areas, the tan areas, are just the opposite. So there's an enhanced chance for places like southern Colorado, southern high plains to be drier than normal. Okay, that's basically what that means.
But the probabilities are
right. The Ohio Valley looks like it has better probability of being wetter than normal for this period.
But those probabilities around South Dakota are very, very small. So it's really not telling you too much more than equal chances for below or above, unfortunately.
Yeah, I think the way to think about it, you look at the maps and you see the colors, it kind of gives the impression that you're looking at a sort of discrete change all of a sudden in terms of what's projected. But as you mentioned, Dan, it's a really a pretty fine gradient to the south, where it's just slightly above average chance of being above normal or below normal precip, and then to get to the north, just a little bit above or a little enhanced probability of being wetter than normal. So it's not a fundamental change at that border by any case.
But all of this weighs into the drought outlook. So you guys, you look at this, you look at the temperatures on the left, you look at the precipitation on the right. All of those probabilities weigh heavily on what the drought outlook shows as well. Warm and dry. Yeah, warm and dry generally means drought. Yeah, I think that's a key observation, Doug. That looking at them together, when you overlay the enhanced likelihood of warmer conditions with the enhanced likelihood of drier conditions, that's where that concern comes from. Okay, could you go down to the drought outlook map now?
Yeah, please.
She meant this map. So sorry about that. So here, what's the gradient mean between the greens there? So if you look down at the legend, when it shows that green color, the greenish color, they're actually expecting during this period between now and the end of April for drought to be erased, which means you will have D0, which is not considered a true drought. It just means abnormally dry. D0 or less, or nothing, no yellow there. The tannish area, not the brown, but the sort of light green tannish area, means that the drought's going to continue, but it go from, if you will, a D2 level to a D1 level. In other words, the drought severity becomes less. Where you see yellow, they're expecting drought to develop. where in the brown area is where there already is some drought, and nobody they don't expect it to get any better. It doesn't say it's going to get worse, but it also doesn't say it's going to get better. It could get worse. So this is their best guess, if you will, for what's going to happen with the drought through this period to the end of April. And then this is a good question, the comparison with the 2012 winter. Again, we talked about this, a few of us yesterday, and there were some people talking about if this compares to 2012, and so far it doesn't. Although 2012 had a relatively mild, I do believe, early winter. I'm sorry, the whole winter was relatively mild and extremely warm in March. We'll have to see if that happens or not, but certainly no one's predicting that. And the fall of 2011, I think, was relatively warm as well, and so was 2017, up until we got the Arctic air down here in the end of December of this year. So there's not a lot of comparisons other than the fact it was the second year of a La Nina, back-to-back La Nina years. Now, we don't know enough to say for sure whether back-to-back La Nina years leads to widespread drought across the United States, or anywhere in the United States for that matter. But we have seen a few instances where that has occurred. Any other comments from the staff here?
Yeah, I'll offer one comment. Again, having looked back at some of these climagraphs of temperature patterns through the year, you mentioned 2012. We got into an exceptionally warm period in March, and then actually, I know in Kentucky, and I suspect in other areas, March was actually warmer than April overall. But if we're starting to see this projection of above normal temperatures coming back after all this cold. So if we get into this sort of oscillating pattern of lately been dominated by the extreme cold, but if we start to see that oscillating more to warming up and then cooling off, and that pattern persists, then there might be some concerns of a similar warm period developing or then being followed by a freeze. But again, that's way too early to say, but it's just something to start paying attention to.
All right. It's 2:00, and so I'm going to let folks go. I think we've kept you here long enough. If you do have any other questions, feel free to email any of us, and we'll do our best to answer those questions as we go along. In February, we'll be back on the 15th, 1 p.m. Central Time. We're still lining up the speaker, so TBD on who that will be. So we really appreciate your questions and your attendance today. So thank you very much, and we will talk to you next month. Thank you, Stuart, and thank you, Dennis, as well.
Very welcome. Take care.